Hi, welcome to the video for Consultation Worksheet 20. Alright, so let's begin with question 1. Okay, question 1, you're provided with the diagram where the curve y equals to 2 ln bracket x plus 3 is given and an unknown line. Alright, the equation is not given and the line is given to meet the curve at this point, minus 1p. Okay, so for part A, you are required to find the values of P and Q. Okay, so let's begin with finding P first. Alright, as we can see that the x coordinate is -1, so this is quite clear cut. For A, you let x be equals to -1, and if you sub it into the equation of the curve, okay, you should get your y to be 2 ln 2. Okay, you can also write this as ln 4 based on your logarithmic laws. Alright, you bring the 2 up, okay, and then you will have ln 4. Okay, so therefore my value of P will be 2 ln 2. Okay, or you can write it as ln 4. Alright, I'm writing it as 2 ln 2 because later when I calculate B, it is actually easier. You'll see that later. Okay, so likewise when we need to find our value of Q, okay, it falls on the curve, but this time round it also falls on the y-axis. So therefore, I know that I can let at x equal to 0, I will have my y to be equals to 2 ln 3 or ln 9. Okay, so here I have my P to be 2 ln 2 and my Q to be 2 ln 3. So that is for part A. Okay, so let's move on to part B. Part B, we are required to find the shaded region as shown in our diagram here. Alright, so as we all know that we are unable to integrate the ln function yet. Alright, so intuitively what I want to do is of course to make my x the subject so that I have a function in terms of y and I can integrate with respect to y. So if you were to do that, so let's visualize our diagram first. Okay, so from our diagram, we can actually rotate. Okay, so bear with me first, I'll rotate it back. Alright, rotate it back, rotate, and we can see that here we are actually finding the area under the y-axis graph. Agree? So what I'm trying to say is we're finding this area here and it's below the y-axis. Alright, so if we were to integrate this function with respect to x, okay, definitely we need to put the, yes, the modular sign, okay, here because it's below the y-axis, okay. And if we're able to find this area, what is missing now? Yeah, this area of the triangle here. So our job now is to find the area of the triangle as mentioned, and then we will integrate this area here and apply the modular sign to give us the required area. Okay, so with that, let's turn it back. Okay, and let's begin with our working. So we have our y to be equals to 2 ln bracket x plus 3. Okay, so bear in mind that we want to make x the subject now. So before that, we are going to divide by 2 on both sides. Okay, and then we're gonna convert this into the e form. Alright, we should get e to the power of y over 2 to be equals to e to the power of ln bracket x plus 3. Okay, and that will give me e to the power of y over 2 equals to x plus 3. Okay, and x should give me e to the power of y over 2 minus 3. Alright, so this is what we have for our function in terms of x. So our required area that will be as mentioned earlier. Okay, if you look back at the diagram, you're going to find the area of the triangle first. Okay, so the base of the triangle, it will be the value of p, which is 2 ln 2 minus half. Alright, the height here, it will be 1. Okay, so our area of the triangle, that will be half times 2 ln 2 minus half, which is 0.5 times by 1, plus the integration from 2 ln 2 to 2 ln 3 of our function above, which is e to the power y over 2 minus 3 dy. Okay, but wait a minute here. As mentioned earlier, this area, okay, it's below the y-axis, so therefore we need to apply the modular sign here. Okay, so let's continue with our working. Alright, on the left hand side here, if you press the calculator, you should get this to be 0.443147. Okay, on the right hand, on the second term here, we can rewrite this as minus, okay, 2 ln 3, sorry, 2 ln 2 this is 2 ln 3 e to the power y over 2 minus 3 dy. Alright, so let's continue with our integration. Okay, integrating this should give me a 2 e to the power y over 2 minus 3y. Alright, this is 2 ln 2 and a 2 ln 3. Okay, so if we substitute our values in, that should give me 2 e to the power of ln 3. So you see here that this is why I was writing it in the 2 outside here, because eventually it will be divided by the 2 in the e power. Alright, so that is on the high side I realize it. Okay, so here I will have 2 e to the power ln 3 minus 6 ln 3 plus 2 e to the power ln 2 minus 6 ln 2. Okay, so let's if you eventually solve it, you should get it to be 0.876 units squared. Alright, and this is to 3 SF. So there you go, that will be the answer for question 1. Alright, for question 2, you are given the equation of the curve and you realize that the equation of curve x is the subject. Alright, so intuitively, this is quite a good hint for you that you probably have to integrate with respect to y. Okay, you're also given the equation of a straight line which intersects with the curve at the point P and Q. Okay, so for A, you are supposed to find the coordinates of P and Q, which I believe everyone should be able to solve the simultaneous equation. Alright, to obtain the coordinate of P to be 0, 3 and Q to be 4, minus 1. In fact, some of you might even recognize or observe that P do not have to be obtained by simultaneous equation, okay? Because P is namely the y-intercept of my straight line, okay? So this part, the workings are omitted, so let's move on to B. Okay, for B, you are required to find the area of the shaded region. So there are many different methods to find the area of the shaded region. I'm going to offer you one of the easier ways to understand for me. Okay, so for me, I will personally find the area of this green part first, which is below the, to the left of the y-axis, not below. Okay, and then I will find the area of this triangle, okay, subtracted with the area, okay, sort of below the curve. Okay, so first thing, let's write that down. So the area, the shaded region, there will be, as mentioned, the area to the left of my y-axis. Therefore, I will need to apply the modular sign. Yeah, so this is 0 to 3 of y squared minus 3y dy plus by the area of the big triangle. Okay, this is given to be 4, and this is also 4 because y coordinate of P is 3. Alright, the y coordinate of Q is -1. Yeah, so this is half times 4 times 4 minus away the area as mentioned earlier. Alright, so with that, let's continue our integration. We have this to be y cubed over 3 minus 3y squared over 2, 3 plus, this is 8 minus the same integration. Okay, so if you were to substitute the values in, okay, we will have this to be minus 3 cubed over 2. okay, because 3 squared is 3 squared, 3 squared times 3 is 3 cubed, plus 8, and here minus 0 minus negative 1 cubed over 3 plus 3 minus 1 square over 2. Okay, so in case you are wondering how can this become a plus, because you sub 0 in, you have 0 minus the entire thing bracket, correct? So with negative times negative, it becomes positive in case you are wondering. So running out of space, let's move it up. So this will give me 4.5 plus 8 minus 1 whole 5 over 6. Okay, so if you solve this, eventually you get this to be 10 and 2/3 units squared. Okay, so let's write this properly. Six. Okay, I'm sure there are other methods to do this, and some methods might be even faster. Alright, if you're interested, there are 2 more alternative approaches you can use to find the area, and they are included in the solution uploaded in Dropbox. Alright, for question 3, we are supposed to find the shaded area as seen in our diagram here, which is bounded by our curve y equals to sine 2x plus pi over 3 and y equals to 1. Alright, so everyone should be familiar with this kind of question where you're supposed to find the area of the rectangle minus the area under the sine graph from A to B. Okay, we do not have the coordinates, the x coordinate of point A and point B, so let's find that first. Alright, to find A, we're going to use, okay, when y is equals to 1. So from here, we can solve this quickly. We will have y equals to, which is sine 2x plus pi over 3 equals to 1. So we will have 2x plus pi over 3 to be pi over 2. And therefore, we will solve this to give me x to be pi over 12. So this pi over 12 is the x coordinate of A. Likewise, we will have to find the coordinate of x coordinate of B. We see that the curve actually touches the x-axis. So that is when y is 0. So when y is 0, we have sine 2x plus pi over 3 equals to 0. So solving this, I will have 2x plus pi over 3 to be pi. So then we will have x to be pi over 3. So this will be pi over 3 namely, yeah. Alright, some of you might be wondering when sine of whatever it is 0, the first angle is 0. But if you let the angle be 0 here, you see that x will become a negative value, which is not what we want for our question. Okay, so having these 2 values now, let's find our required area. Okay, so our required area would be the area of the rectangle, which is 1. Alright, as we can see from the diagram here, that's the height of the rectangle, the length of the rectangle. Okay, so this will give me 1 multiplied by pi over 3 minus pi over 12, okay, minus area under the graph, okay, which is integration from not pi over 3 but pi over 12, yeah. So pi over 3 to pi over 12 of sine bracket 2x plus pi over 3 dx. Okay, so here the first term, if you simplify it, you should get pi over 4 minus, okay, integrating sine will give me a negative cosine 2x plus pi over 3, okay, over 2. Don't forget your chain rule, yeah. Okay, this will give me pi over 12 pi over 3. Okay, so from here, to simplify our working, I'm going to factorize out the negative half first. So this is what I'm left with inside. Sine 2x plus pi over 3. Okay, pi over 12 pi over 3. The limits remain the same there. Alright, let me finish the bracket. Okay, So if we substitute the value in, we will have pi over 4 plus half. Okay, the first term you substitute pi over 3, you should get this to be cosine pi minus cosine pi over 2. Okay, so from there, okay, we see that cosine pi is actually -1, okay, and cosine pi over 2 is 0. So our answer will just be pi over 4 minus half, or we can leave it in 3SF, which is 0.285 unit square in 3SF. Alright, so that will be our answer for question 3. Alright, for question 4, please make sure that the copy of consult worksheet you have is the amended one where, alright, this is mentioned, okay, t seconds after the start of the motion is already added. If not, if you're having the old version of the worksheet, please add that in. Alright, so let's read that question. A particle starts from a fixed point O along a straight line, and you are given the displacement function here. Okay, so let's read through part 1 to part 4. Part 1 asks about when the particle is at O again. Okay, so that means that probably we will need to find out the time where your displacement is equal to 0. Okay, so for part 2, where you are supposed to find the times when the particle is at rest, okay, and what do you understand by at rest? Yep, that means that our velocity is equal to 0 lah, huh? Okay, and for part 3 and part 4, we will do them in a while. So part 3, distance traveled during the third second, we will need to find the displacement first. Okay, at t equals to 2, what is my displacement? Likewise, when t equals to 3, what is the displacement? And then we try to find the distance from there. Okay, so for part 4, the time interval during which the velocity is decreasing. So for velocity decreasing, we are looking at the dv dt to be negative, and that would be my acceleration. Yeah, alright, so without further ado, let's start the question. So for question 1, okay, the time when a particle is at O again, so as mentioned earlier, this is when displacement equal to 0. So we will have t bracket t minus 4 square to be equal to 0, and this will give me t equal to 0 or t equals to 4. So therefore, the time where the particle is at O again, okay, is at the 4 seconds. So you can just write at 4 seconds. Alternatively, you can also write it as at t equals to 4. Okay, so for part 2, so the times when a particle is at rest, so we are finding out when our velocity is equal to 0. Okay, so since we are given the displacement function to find our velocity, we are finding the ds dt, and this is actually my velocity. Okay, so let's perform the product rule here to get our v. Okay, so if you perform our product rule, we will have t minus 4 square plus t for 2, and then we have a t minus 4. Okay, so here if I factorize out a t minus 4, I'll be left with a t minus 4 plus 2t. Okay, and this will give me t minus 4 bracket 3t minus 4. Alright, so let's shift up a bit. So if you have not copied, please pause the video, yeah? Okay, so from here, at v equals to 0, we will have 0 to be equals to t minus 4 and 3t minus 4. And this will give me t to be 4 over 3 or t to be 4. So therefore, the particle is at rest again at 4 over 3 seconds and at 4 seconds. Alright, so that will be our part 2. Let's move on to part 3. Okay, for part 3, at t equals to 2, we will work out our displacement to be 8 meters. Okay, likewise, at t equals to 3, our displacement is actually 3 meters. So from here we see that the particle, okay, and have traveled how much? So the total distance will just be 8 minus 3, which is 5 meters. Okay, so therefore distance traveled in the third second is 5 meters. Alright, so that will be for part 3. Alright, for part 4, supposed to find the time interval during which the velocity is decreasing. So as mentioned earlier, we need to find out where our acceleration is less than 0. Okay, but before that, we do not have our acceleration function, so let's perform the product rule to my v, okay, which we have differentiated earlier, which is this. Okay, so likewise, I'm going to perform the product rule, okay, and you should get your acceleration to be 3t minus 4 plus 3 bracket t minus 4. Okay, so with simple simplification, you should get this to be 6t minus 16. So for our acceleration to be less than 0, you have 6t minus 16 to be less than 0, likewise, and therefore t will be less than 8 over 3. But since t represents time, time can be more than or equals to 0. So we will have our time interval to be more than or equals to 0 and less than 3. Alright, so that will be our answer for part 4. Okay, for question 5, let's read the question first. A particle moves in a straight line so that time t seconds after leaving a fixed point O, you are given the displacement function as seen here. Okay, calculate the value of t when the particle is momentarily at rest. Similar to question 4, alright, when a particle is momentarily at rest, we're talking about when the velocity is 0. Okay, and part 2, you're supposed to find the distance traveled by the particle in the first 5 seconds. Alright, so let's begin with part 1. Okay, we are given our displacement function to be as such. Okay, so we know that velocity is the differentiation of my displacement. So by our product rule, we will have this to be e to the power minus half t minus t over 2 e to the power of negative t over 2. Okay, so we can factorize out our common term first, and this will be 1 minus t over 2. Okay, so since it's momentarily at rest, we will have at v equals to 0, e to the power negative half t, 1 minus t over 2 equals to 0. Okay, so eventually we'll have e to the power of negative t equal to 0, which we know is not possible because the exponential graph can never be 0, right? Okay, or we have 1 minus t over 2 to be 0, which we can solve it to give us t to be 2. So the value of t here will just be 2. Alright, for part 2, when I'm supposed to find the distance traveled by the particle in the first 5 seconds, alright, it will be wrong for us to just do at t equals to 5 seconds, and then we just find our s here to be e to the power of negative 5 over 2, and to just find this answer 0.410.425 in 6 SF, and then we conclude that the distance traveled is this. Okay, why is it wrong? Because we have to understand the behavior of this particle now. Alright, that at the start, okay, it's probably traveling to the right, I would say. How would I know that? Okay, let's find out first at the instant where it became momentarily at rest. So we will have at t equals to 2, we have s to be equals to 2e to the power minus 1, okay, which is 0.735759. 735759, okay, 6 SF. So you can see that this displacement is really bigger than this value, right? Therefore, as mentioned earlier, you cannot just conclude it that the distance traveled for the first 5 seconds to be this, because the particle did turn around. Alright, so the total distance expected will actually be more. Okay, and how do I know that I need to sub in t equals to 2? That is because I know that the particle was momentarily at rest at time equals to 2. So if you were to draw the diagram out, how would the behavior of the particle look like? Okay, so at the first instance, at t equals to 2, he has traveled to here 0.73579. Okay, after it was momentarily at rest at time equals to 2, we see that the displacement has decreased here, correct, to be 0.410425. So what has happened is, yep, it has went back to the left, okay, such that the displacement here is 0.410425. Okay, so the distance traveled, okay, will be this part, everything in green, yeah? Good with that? Alright, so let's write it out. So the distance traveled, okay, we can call it the total distance. That will be 0.735759, 735759, okay, plus by 735759 minus away 410425, yeah? Alright, so if you were to round it off to 3 SF, you should get it to be 1.06 meters. Okay, so that will be the answer for 5 part 2. Okay, so we have come to the end of the consultation worksheet. Thank you for listening.